Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our lecture number 10 of our free course Design of Transmission Lines and Distribution Lines. In previous lectures, we have studied about letter of intent, bill of quantity and estimation, survey of power lines, permissions needed for transmission and distribution lines, load, connected load, maximum demand, demand factor and diversity factor. SLD preparation, that is the single line diagram or one line diagram using Etap and Autocad. Nominal voltage and rated voltage, calculating phase to phase clearance of transmission lines, phase to ground vertical clearance of transmission lines, phase to ground horizontal clearance of transmission lines, calculating the weight of steel, structural drawings, clearance from highest point of the building, height of towers for different voltage levels. In today's lecture, we will study about span of transmission lines, type of towers, calculate number of disc insulators used for transmission lines, calculate the cable size. Before starting the lecture, please subscribe the channel, like and share the videos on your social media profiles. Let us start the lecture. One of the subscriber has asked the question. Thanks for great explanation. Thank you, sir. How to find distance between two poles or towers? That is, it is asking about the span. That is how to find the span of a tower or between the two poles, how to find the span. This question can be addressed in this lecture. We have to study about the span of transmission lines. The second question is how to find the pole or tower depth in earth. That means I think the subscriber wants to ask what is the depth of the pole, what should be the depth of the pole from the ground level. Generally, the depth of the pole is taken 1/6 of the pole length. If our pole is of 11 meter, the pole depth from ground level is pole length divided by 6. That is pole depth from ground level, it becomes 11 divided by 6, that is 1.8 meters. Similarly, if our pole is of 9 meter, we can get the depth of the pole 9/6. Similarly, if our pole is of 13 meter, then 13/6. Now the question remains is how to find the depth of the towers. Tower structures, how to find the depth. For that, in every organization there is a structure engineer which is mainly concerned with the civil department. You can contact him with the structure engineer and ask about the structure drawings and about the pole depth, about the foundation drawing of the transmission tower. This part is not of electrical part, it is actually of civil part. But generally about 3 meters depth is taken from the ground level. But for proper depth, proper dimensions of the foundation of the tower, you have to consult the structure engineer. Now start today's lecture. Normal speed of transmission lines and distribution lines. In this part, we will see what is with the normal span of various transmission lines. First of all, we will see what is the span. What does the span mean? The horizontal distance between two towers or a poles is called the span. It is the horizontal distance between two towers or two poles that is called the span. That means it is that this distance. This is the distance. This distance is called the span. Now, what are the factors on which the span depends? The various factors on which the span depends are voltage level, line to line voltage. What will with the line to line voltage? If the voltage of a line is less, the span will be less. That means the span of 11 kV line is less as compared to span of 33 kV line. Similarly, the span of 33 kV is less as compared to the span of 66 kV line. Second is structure height. Taller structure, longer is the span. With the increase of the height of the tower or height of the pole, the span is longer. The span of the line will be longer. And third is the crossing. It also depends on the crossing like railway, road, telephone lines, because here we have to maintain the proper clearance between the, if we are going for the highways, then we have to think about the crossing of vehicles. On that basis we can keep the span of the between the two poles, so that the proper height should be remain from road and the line. Now this is the chart giving you the various spans of various voltage level at various voltage level. This is the voltage level column and this is the height of tower. For LT lines, the span is generally 25 meters. That is the distance between two poles is generally 25 meters. For 11 kV line, the span is 30 to 35 meters. For 33 kV line, it is 35 to 40 meters. For 66 kV line, it is 250 meters. For 132 kV line, it is 320 meters. And for 220 kV line, it is 350 meters. And for 400 kV line, it is 380 meters. And for 765 meters, for 765 voltage level, it is generally 400 meters. These are the normal spans. These normal spans can vary depending upon your condition. You have to think about, you have to keep the proper clearance from ground and the transmission line. Accordingly, you can select the span of the line. But these are the normal spans. If you have a normal plan and you are going for the laying of the transmission line, these are the normal spans. Now, type of towers. Generally, there are 4 types of towers depending upon the angle of deviation. Type A tower has the angle of deviation 0 to 2 degree. If the tower has 2 to 15 degree angle deviation, this tower is called type B tower. If it has 15 by 30, 15 to 30 degree angle deviation, it has a type C tower. And above 30 degree angle deviation, it is type D tower. Now, what is the angle deviation? You can see here, this is the 60 degree angle deviation. Line is coming from this side or this side, and line is coming from this side and going to this side. It is not just passing here, but diverting the path. This is called the angle deviation. That is the deviation of the line from the straight path. The straight path is like this, but it is deviating to this direction. This is called the angle deviation. It is 60 degree. Here the angle deviation is 60 degree. So it is type D tower. Calculating the number of disc insulators. You know the disc insulator or pin insulator or insulator. Various types of insulators are used in transmission lines from distribution level to transmission. In LT lines, shackle insulators are generally used. You have seen it on the poles. This is called the shackle insulator. This is the 11 kV pin insulator, and this is the 33 kV pin insulator. This is a porcelain material, made of porcelain material, and this is made of polymer. Similarly, it is a polymer pin insulator, 33 kV pin insulator, and this is a porcelain pin insulator. And this is the disc insulator. One disc insulator can withstand the 11 kV volt, and when we have to more than 11 kV voltage, we have a 66 kV voltage and 33 kV, 66 or 220 kV voltage. Then we can add different number of disc insulators to make a suspension insulator like this. This is the suspension insulator. You can see here the number of disc insulators are joined together to make a suspension insulator. Now we will calculate how you can calculate the number of discs required to join so that the proper insulation will be provided to the voltage line, to the transmission line. First of all, I will show you how many number of disc insulators are used for different voltage levels. For LT line, shackle insulators are used. This picture I have already shown you. For 11 kV line, the 11 kV pin insulators are used, and one disc insulator is used at the tension pointers. At the tension pointers, pin insulators are not used, but disc insulators are used. One disc insulator is used in the 11 kV voltage at the tension pointers. For 33 kV line, 33 kV pin insulators are used, but at tension pointers, pin insulators are not used, but 3 disc insulators are joined together and used at the tension pointers. For 66 kV line, 5 to 6 disc insulators are used for 132 kV line. 8 to 9 disc insulators are used for 220 kV line. 12 to 13 disc insulators are used to make the suspension insulator. For 400 kV line, 22 to 23 disc insulators are used to make the suspension insulator. For 765 kilovolt line, 42 to 43 disc insulators are used to make the suspension insulator. Now, how do we calculate? If you do not know this number of discs are used, how many number of disc insulators are used, how to calculate these things? I will take the example of 400 kV line. For 400 kV line, the line voltage is 400 kV. The number of disc insulators are equals to line voltage divided by root 3 into disc voltage, that is the voltage of one disc plus safety factor. Generally, the safety factor is taken 1.5. Disc insulator is 111 kV. That means the disc voltage. The one disc insulator can withstand 11 kV. They have the voltage rating of 11 kV. The number of disc insulators is equal to 400. That is the line-to-line voltage divided by root 3 of formula and into disc voltage, that is the voltage of a one disc, that is 11 kV plus safety factor, that is 1.5. It becomes 20.99 plus 155, that is 2.49, approximately 22. That is, we have written here 22 to 23. 23 is used as tension pointers and 22 is used as general purpose. When the line is going straight, it is not tension point. Other than tension point is 22 disc insulators are used. At tension point is 23 disc insulators are used. Calculation of cable size. We have given a separate lecture on these. 3 lectures are given on this calculation of cable size. They are available on my YouTube channel. I will show you. This is my YouTube channel. From here you can see, go to playlist, and in the playlist you can see cable sizing, selection of cable sizing and voltage drop calculation. See, all the things are mentioned here. You can see lecture first, calculate how to calculate the cable size. These 3 lectures will cover you this topic, calculation of cable size and voltage drop. In addition to that, say calculation of cable size. Complete things are mentioned. Detailed discussion is going on cable sizing here. We have also show you how to calculate the cable size in Etap and in the Excel sheet. All these things are mentioned and discussed in this playlist. You can watch this playlist one by one. Why proper cable sizing is required, all the things are discussed here.